Welcome to the Precalculus Practice Final Exam video. So for number 1, we're looking for a coterminal angle. So we're given the angle 11 pi over 4, which is in radians, and we want a coterminal angle that's between 0 and 2 pi. So we know that coterminal angles occur every full rotation, or 2 pi radians. Since 11 pi over 4 is bigger than 2 pi radians, we'll need to subtract. So we find a common denominator, which should be 4. And we get 3 pi over 4. If you're having issues with the fractions, if you type 11 over 4 minus 2, so don't put the pi in the calculator, you'll see that it's 3/4. So we get 3 pi over 4. Okay, number 2, we have another coterminal angle problem. This one's in degrees. So instead of 2 pi radians, a full rotation in degrees is 360 degrees. We want the angle between 0 and 360, and we see that our angle is negative. Now, if I add 360 degrees, we get negative 63 degrees, which is not between 0 and 360, so we just need to add another full rotation. And that gives us our answer, 297 degrees. Okay, for number 3, we're looking for a complementary angle. Now, two complementary angles, their measures add up to 90 degrees or pi over 2 radians. So we're given one angle, pi over 6. So we subtract pi over 2 minus pi over 6. So a common denominator would be 6. So we get 3 pi over 6 minus pi over 6 is 2 pi over 6, which reduces to pi over 3. So if we put it in the calculator, the fractions, don't put pi in the calculator, you get 1/3, which represents the pi over 3. Okay, at number 4, we have radian measure, and we want to convert to degrees. So we know that 2 pi radians is equal to 360 degrees. So 1 pi radians is equal to 180 degrees. So if I take 5 pi over 12, I'm going to multiply by, quote-unquote, 1, 180 degrees over pi radians. So the pi's cancel out. Oops, sorry about that. I meant divided by 12, not 120. There we go. And we get 75 degrees. Okay, for the next one, we're going from degrees to radians. So now we're going to multiply by pi radians over 180 degrees. And we get 5 pi over 36. Okay, for number 6, we have an arc length problem. And the formula we're going to use is S equals R theta, where S is the arc length, R is the radius, and theta is the measure of the central angle in radians. So I just substitute the values I know from the problem. R is 16, and S is 19.36. So now I solve for theta. And I get 1.21 radians. Now, if this was the question and I didn't say anything else, this would have been an acceptable answer. But we see the answer key has the answer in degrees, so let's go ahead and convert it to degrees. So we take 1.21 radians times 180 degrees over pi radians. Now, notice in this problem there's no pi in this, so there's no pi's that cancel out. So we're just going to type it in as we see it here. And we see we get about 69.33 degrees. Okay, number 7, we have another problem dealing with arc length, still using S equals R theta. But recall what I said for problem number 6 is that theta needs to be in radians. So our central angle is 45 degrees. So we'll change that to radians, and we get pi over 4. So 16 equals the radius times pi over 4. Now, it's going to be very easy to make a mistake on entering this into the calculator. You need to put parentheses around the pi over 4. If you don't, you're going to get a different answer that's wrong. You can see that our answer matches. We get about 20.37 inches. Okay, for number 8, it's a linear speed problem. And linear speed is equal to the length of the arc divided by time. So in this problem, we know that the second hand, which has a radius, which is 9.7 centimeters long, is going to make a full rotation every 60 seconds. So, the circumference of a circle is 2 pi times radius. In this problem, the radius is 9.7 centimeters. we get about 1.02 centimeters per second.